Alrighty, let's look into this regions problem. So, alright, it says do now. Solve 6x squared minus 42 equals 0 for the exact values of x. Alright, so I don't want that minus 42 there, so I'm going to add 42 to both sides because I'm trying to get this 6x by itself. This is just one way you could solve it. So then this would give me 6x squared equals, that would be 42. Then I want to get rid of this 6, so I'm going to divide out 6. So I would get x squared equals 42 divided by 6 gets me 7. And now I don't want that squared there, so I'm going to square both sides. And that would give me x equals plus or minus the square root of 7. Let me show you another way you might have thought to do it. Another way you might have thought to do it was, let me factor. Alright, so let's think about factoring. I want to think about my GCF. The number they both have in common is 6. So that would give me 6x squared minus 7 equals 0. I would then write 6 equal to 0. That would never work. And then I would write x squared minus 7 equals 0. Add 7 to both sides. I get x squared equals 7. You have to take the square root of both sides. So that would give me plus or minus 7. Or one last thing that you might have thought to do is maybe use the quadratic formula. When you have 6x squared minus 42, your a equals 6, your b is unknown, well, your b is not there, so it's 0, and your c is negative 42. And then you would plug it into the formula. Negative b is 0, plus or minus the square root of b, which is 0 squared, minus 4, a is 6, and ac is negative 42. All over 2a, so 2 times 6. So we would have negative 0, which is just nothing. So then we'd have plus or minus 0 squared minus 4 times 6 times negative 42. That would give us 1008 divided by 12. I'm then going to think about a perfect square that could go into that. Let me think. Maybe 144, yep. 144 and 7 over 12. The square root of 144 simplifies to 12, square root of 7 over 12. Cancel out the 12s, and guess what? We end up with the same answer. So that is 3 different methods that we have learned that all work for the same exact regions questions. And because it says the exact value of x, that means you need to give them exactly what the perfect square is. Don't give them the decimal. The square root of 7 is this big, long decimal. If they asked you to round to a certain number, then you would tell them 2.6, 2.65, depending on what they told you to round to. But here they want the exact value, and that would be the perfect square, the square root. All right, so what are we going to do today? Today we are going to learn how to apply the methods of solving quadratic equations by solving real-world problems. Let's look into it. Regis question. The expression this represents the height in meters of a toy rocket t seconds after launch. The initial height of the rocket in meters is, let's type this in, negative 4.9, I'm just going to put x squared, plus 50x, one second. One second, guys. Okay, 50, I don't know what was just happening, plus 2. I'm just typing it in. Okay. Now, they want to know the initial height. It says the initial height. Initial height means where does it start? Meaning that you want to know when the height was at 0 seconds, technically t equals 0, when the height was at 0 seconds, what was the height? So let's go look at the table. At 0, it was 2. 2 meters above the floor. So the answer is 2. And that makes sense because if you plugged 0 into this equation, this part with the variable would cancel out, this part with the variable would cancel out, and you'd just be left with 2. All right, let's look at our next one. The height of a ball during tossed into the air can be modeled by this function. where x is the time elapsed in seconds and h of x is the height in meters. The number 5 in the function represents the initial height of the ball. I think that makes sense because if I plugged 0 in for x, both of those would cancel out and I'd just be left with 5. That makes sense. The next one says the time at which the ball reaches the ground. Let's go type this in and see what happens. Negative 4.9x squared plus 6x plus 5. Let's go see the table. I like looking at the table. When does it hit the ground? Well, I see here it's negative, and we can't talk about it being negative. So it's going to hit the ground somewhere in between this 1 and 2. So it's not going to be choice 2. Then 3 says the time at which the ball was at the highest point. Well, it was at the highest point somewhere in after 1, because then it went to the lowest point. So it's not going to be that. And number 4 says the maximum height of the ball obtained. Well, it definitely went higher than 5 because I see it went to 6.1, so that's not it. So the answer is the initial height of the ball. Think of it like your y-intercept, the number that's by itself. That's where it starts, and it's starting at 5. All right, pause the video and see if you can figure this one out. Ian throws a ball up in the air and lets it fall to the ground. The height of the ball, h of t, is modeled by the equation h of t equals, and they give us this function, where with h of t measured in feet and time measured in seconds. The number 3 represents, well, hopefully you're realizing this number by itself talks about the starting height. So it's not going to be the maximum height. The height from which the ball is thrown, that makes sense. The number of seconds, no, the 3 has nothing to do with the seconds. Because seconds would have to be something with the t, the time, and the number of seconds, no. So 2 sounds great. The 3 is the initial height, the height at which the ball is thrown, the starting height. That's why the number is by itself. All right, let's look at the next one. Brian is 3 years older than Doug. So Brian's age equals 3 years plus Doug's, because he's 3 years older. The product of their ages is 40. I don't know how old Doug is, so I'm just going to put a D. All right, product. Product means to multiply. So let me multiply these two things. 3 plus D times D equals 40. Let's do this problem. 3 times 3 is 3D. D times D is D squared equals 40. Let me see what we can do here. Let's try subtracting 40 and get it equal to 0. So that would give me D squared plus 3D, I just want to write it in standard form, minus 40 equals 0. I'm going to see if I can factor here. Can I find a number that adds to 3 and multiplies to negative 40? Let's think about it. What numbers multiply to 40? 1 and 40, that will never be 3. 2 and 20, 4 and 10, that's not going to work. 5 and 8. Ooh, 5 and 8 could work. Let's have D plus 8 and D minus 5 equals 0. Now we could set each of these equal to 0. D plus 8 equals 0. That's going to give me that Doug is negative 8 years old. I don't think that makes sense. Or Doug minus 5 equals 0. Let's add 5 to both sides. That would give me Doug is equal to 5. That makes sense. You could have also done this without doing any of this real work, and let's think about it. We know that Brian is 3 years older than Doug, so each of these, let's add 3 years to them. 8, 11, this would be 8, this would be 4, 5, 6, 7. And then we just have to see, do the products equal 40? And the only one that the product equals 40 is choice 3. 5 times 8 equals 40. All right, let's look at the next question. Ooh, this is kind of the same question. You do it. This person is 5 years older than Jacob. No G. No G equals 5 years plus Jacob. And we know that Jacob is just Jacob. And it says their product of their ages is 84. 5 times J is 5J. J times J is J squared equals 84. Let's subtract the 84 and let's put this all in standard form. J squared plus 5J minus 84 equals 0. Now we're going to need to find what adds to 5 and multiplies to 84. I don't remember the factors of 84, so in my calculator I could do 84 divided by x, and then I could go and look and see 1 and 84, that's not good. 2 and 42, 3 and 28, 4 and 21. 6 and 14, does that equal 5? No. 7 and 12, that sounds great. J plus 12 and J minus 7 equals 0. So this would end up equaling J is negative 12 years old. That doesn't make sense. Or J is 7 years old. That sounds good. But they don't want to know how much Jacob is. They want to know how much Noji is. And we know that Noji equals 5 plus Jacob. So let's do 5 plus 7, which equals 12. Again, you technically didn't have to do this. We know these are all the ages of Noji. And then we know that Jacob is technically 5 years younger. So this would be 1, 2, we're just subtracting 5. This would be 7, and this would be 9. And then multiply them together and see which one equals 84. It would be choice 3. All right, let's look at the next question. Sam and Jeremy have ages that are consecutive odd integers. Ooh, I like that. If you remember odd integers, you start with x, and then the next one is x plus 2. Because think about it. If you want the odd numbers 1, 3, 5, the only way to get to the next number is by adding 2. So we call this one x, and then to get to the next one, we add 2. That's how consecutive odd integers work. They're telling us that the product of their ages is 783. Which equation can be used to find Jeremy's age J if he was the younger man? So the younger man is J, and the next man is J plus 2. And it says the product, so we have to multiply these two things together, equals 783. So J times J is J squared, and J times 2 is 2J, equals 783. And that is answer choice 3. Nice. All right, let's look at this next question. Try it. Pause the video, see if you can figure it out. Abigail and Gianna's ages are consecutive integers. So it doesn't talk about even or odd, it just says consecutive. Abigail is younger than Gina. Gina's age is represented by x. So Gina equals x. Abigail is younger. So if Abigail is younger, if you want to go backwards, you'd have to do x minus 1. Because let's just say that Gina is 4, and we want to go to a younger person, to Abigail, she would have to be 3, and that means we're subtracting 1. All right. It then says, if the difference of the square of Gianna's ages, okay, so we have Gianna squared, so x squared, and 8 times Abigail's age. 8 times Abigail's age is 17. Which equations can be used to find this answer? If the difference of the square of Gianna's ages, so Gianna's x, so x squared, and 8 times Abigail, so 8 times x minus 1 is 17. So this would be x squared minus 8 times x is 8x, and negative 8 times negative 1 is positive 8, equals 17. Well, I actually just did more work because they didn't even ask me to do all that. My answer was just choice 3. And you could pause the video and practice solving that to find their ages. All right, let's look at the next question. Oh, I almost picked the wrong one. I meant to do the minus 1. It's actually choice 4. I accidentally got tricked by that plus 1. All right, let's look at the next equation. When Albert flips open his mathematics textbook, he notices that the product of the page numbers of 2 facing pages. So think about it. When you're facing pages, it would be like this is page 2 and this is page 3, if they're facing each other. So that would be like x and x plus 1. Albert sees that the pages is 156, the product of them. So the product of x and x plus 1 is 156. Product means to multiply, so our answer would be choice 4. All right, let's look at the next question. The length of a rectangular piano is 7 more than its width. So the length is 7 more than the width, and the width is just the width. The area, area means to do length times width. So 7 plus w times the width. Let's see what that gives us. 7 times w is 7w, and w times w is w squared. And let's write it in the correct order. It is choice 2. And let's look at the next question. The length of the shortest side of a right triangle is 8. Okay, so we have a right triangle. The shortest side, so one of these sides, is 8. It then says the length of the other two sides can be represented by consecutive odd integers. So we can just give this x, and then that longest one would be x plus 2. Remember odd? We do x plus 2, x plus 4. Which equation can be used to find these lengths? If you know anything about a right triangle, we use Pythagorean theorem. A squared plus b squared equals c squared. So we would have 8 squared plus x squared equals x plus 2 squared, which is answer choice 4. And let's look at the next question. Joe has a rectangle piano that measures 10 feet by 12. So one side is 10 and the other side is 12. He wants to increase the area by 50%. So let's see what the area is right now. 10 times 12 gives us 120. And he wants to increase it by 50%, which means what is 50% of this? Times 0.5 is 60, so 120 plus 60. He wants to make his new area 180. New area equals 180. Okay, so he wants a new area to equal 180, which is answer choice 2 or answer choice 3. Well, right now he's at 10 and 12. He needs to add something to each of these sides to get it to the new area, which would be choice 2. Very similar question for the next one. So as you go to the next question, I want you to pause the video and try the next question. A farmer has a rectangle field that is 100 feet by 150. So right now it's 100 by 150. And he wants to add equal lengths x. Okay? So that would be 100 plus x and 150 plus x, which is answer choice 3 or 4. He doesn't want it to stay what it is right now. 100 times 150 is 15,000. He wants it to be increased by 20%, so we need a number bigger than 15,000, which is answer choice 3. And let's look at the next question. All right, we are actually done. A good thing that you could do right now is go back and try to solve some of these problems to see if they were long response questions. Now that you have the equations that you chose through this multiple choice, what would be the actual answer? Solve it using the different methods of quadratics that we have learned.